Hello, we are here today to talk about Xilinx 12.1 for the CSULB course CECS 201 for Professor Elson. There are some differences in 12.1 that should probably be explained, and this basic tutorial will hopefully help you guide through Xilinx 12.1. The initial part, when drawing your schematic, is essentially the same as in 10.1. Please refer to Professor Elson's tutorials for that part if you need more help. We will very briefly go over it. Let's begin. First, select New Project. A pop-up like this should come up. What you want to do is to name your project. After you're finished, click Next. Now you want to make sure that the family device and package correspond to your prototyping board. We are currently using the Nexus 2 board, and the family for that is Spartan3E. The device is XC3S500E, and the package is FG320. After you've verified that it corresponds to your board, click Next, then Finish. Basically, an empty project should come up. What you want to do is under Hierarchy, right-click onto the chip. For future reference, right-clicks will be in green and left-clicks will be in red. Once you've right-clicked onto the chip, go over to the new source and click on it. This should pop up. Go over to Schematic and click on it. Now go over to File Name and name it. There are several conventions and rules to naming, such as no caps at the beginning, no spaces, and no numbers at the beginning. Once you've named it, click Next, then Finish. Now this should come up. This process is the same as 10.1, and you can refer to Professor Elson's tutorials for that. Your schematic is on the big open blank area, and if you haven't yet, click on the symbol bar on the bottom to bring up the symbols. And just for your general information, the NOT gate is inverse, so type in INV if you want to find the NOT gate. Once you've done your schematic and saved it, click on Simulation at the top and make sure that you have Behavioral just below it. If not, just expand it and click on Behavioral. What you want to do next is right-click on your schematic that you've just finished and saved, and click New Source. This is different because Xilinx 11 and above do not have test bench waveforms. You'll have to do it in a slightly different way. Go and click on Verilog Test Fixture and name the file. After that is finished, click Next, Next, and Finish. Now something remotely resembling this should come up. Don't worry if it's overwhelming at first, it's relatively easy. First, you want to delete everything boxed in red, basically the pink parts. Here it is line 18 and 20. Once you've deleted it, and under Initial Begin, you want to start writing up your test times and such. First, you pound time 0, open brackets, your input variables, close brackets, equals 4 prime b, the initial binary value, semicolon, and 2 forward slashes, which means comment, and type in the time at just for your convenience. Go to the next line and repeat this process. This time, instead of pound 0, it's pound 100, and of course don't forget to change the binary values and time. For subsequent lines, it'll stay at pound 100. Once you've finished, type in the next line N and save it. And go to your processes and click on Simulate Behavioral Mode. A separate program, iSim, should pop up. It should look roughly like this. Now you want to change the 1 .000us at the top, right to the time required. In this case, since we have 16 outputs, the time should be at 1650 ns. I repeat, 1650 ns. Next, you want to fit the left sides down just to make it look nicer. They don't need that much space anyway, so you can just do that. Next, go up and click on Restart. Then click on Run for the time specified on the toolbar. Go over to Zoom to Full View and click on it. You will also want to switch around the output and input so that it goes in order. Input first, then output. Next, you right click on the name and right click on New and left click on New Divider. Do this twice. One for the top and one just before the output. Then you just add your label to it. Go up to Zoom to Full View and click on it again. You'll want to click on this whenever the right side of your diagram changes, just to fit everything in and make it look nice. Once you've printed out what you need, you will close it and go back to Xilinx. Go back to implementation mode. Click on your schematic and go down to processes. Expand user constraints and click on I/O pin planning post synthesis. Post synthesis, not pre-synthesis. Post. A separate program should run up. This may take a few seconds. Once it appears, you should get something that looks a little like this. What you want to do is expand the scalar ports. Just go over to your outputs and inputs and right click on it. Go over to I/O ports, properties, and click on it. You don't have to do this for every output and input. A small window should highlight just above the I/O ports window. You want to go over and click on float frame there. This should come up. Go over to the site field and change or add a location that corresponds onto your board. For instance, J14 for the output. After you filled it in, click on Apply. Do this for every input and output. Here is just a quick reference to the Nexus 2 board inputs, courtesy of Professor Alson. Now, save it and close it. Go back to Xilinx and click on Generate Programming File under your Processes window. This will take a few minutes. Just wait. Now, connect your board and turn it on. Go over to your Diligent Adept program. This is a separate program from Xilinx and you must download it from the website. I'll show you this later. Now, click on Browse and find where you put your program. Click on the .bit file there and open it. Make sure it is in FPGA. Do not put it in the PROM. To get the program, go to the website above. Once you're there, below under Products should be a list like this. Expand the FPGA boards and click on Nexus 2. Scroll down to Diligent Adept, it's free, and click on it. Download the Adept 2.6.1 system and install it. That's how you get the program. And after that, you just connect it to your, use your Nexus 2 board and demo it.